everyone. Welcome to Msc Chemistry. Today we are going to discuss the CU-CET 2020 and Msc entrance question paper. I going to plan the three part. Okay, first part I going to discuss. Listen, in CU-CET there are two part, right? Part A and part B. The part A should be objective, right? General aptitude, and part B should be chemistry question, right? In part B, there's 75 question, right? In the 75 question, I'm going to discuss for all the inorganic question in the CU-CET 2020 paper. Okay, so I'm going to start the first question. Now see the first question. They're asking what? Which of the following this transition metal complex have correct for del not value? They're asking what? The CFSE value, right? What is a important key point in this question? Listen, we know the CFSE value. The CFSE, crystal stabilization energy. Okay. In case of weak field ligand, always what? Low CFSE, right? The low del O value. In case of strong field ligand, always what? High del O value, right? High del O value. Now, according to petrochemical series, what is petrochemical series in this option? See the option. CN ligand will be there, and ammonia ligand and Cl, right? In case of CN minus and NH3 and Cl, which is strong field ligand, the CN is strong field ligand, right? Therefore, the CN complex have more CFSE compared to an NH3Cl, right? Which is correct answer. Option A is correct for this question. Okay. Next question. They're asking what? The correct name of the complex and Na and platinum BrCl and NH3NO2. Okay. Actually, this question is wrong. Why this wrong mean? Okay. Now see the oxygen of platinum, all the option. -1, -1, -1. Now check the oxygen state here. Sodium +1, right? Then platinum X. Bromine -1. Cl -1. Ammonia neutral ligand. NO2 and +1. C equal to 0, right? Therefore, this +1, this -1 cancel. -1 +1 option should be X equal to 0, right? Therefore, the platinum should be what? 0 oxygen state. What is the given option? -1, -1, right? Actually, this question is wrong. What is the correct molecule? This question should be, okay, Na2 and platinum and Br and Cl and NH3, then NO. Now check the oxygen state. Simple. Na plus, right? 1 into 2. Platinum X. Bromine -1. Cl -1. Ammonia neutral ligand. NO2 +1. Therefore, this +1, this 2, right? 2 plus and X and -1 and +1. Therefore, and 3 plus X and -1, right? Just right. This +1 will cancel, right? Therefore, 2 -1, right? And 2 -1 is equal to X. So X equal to what? S equal to -1. Okay. If you put Na2, the question will be correct. Okay. Actually, the question is wrong in exam. Okay. Then, okay. Let us assume Na2. Okay. What is IUPAC name? We have to assign the what? Based on the alphabet order, right? In case of Br, bromo, Cl, amine, and nitro, which is first in alphabet A, right? Therefore, amine. Therefore, sodium, okay, nitro, right? Wrong answer. Bromido, wrong answer. It will be B and D only, right? Let's check. First amine, then followed by bromo, right? The amine, bromida, good. Then chloro and as well as what? And nitrogen. Please understand. And new update in IUPAC nomenclature. What does new update mean? Okay, in Cl minus, what is the correct name? The chloro is old name. This old one, which is new one, chlorido. Understand? You see, here also bromido, here bromo, here chloro, here chlorido. Okay, these two will be same only, but what is the new update in IUPAC nomenclature? We have to tell the Cl minus as a chlorido, not chloro. Okay, option D is the correct, accurate answer. Okay, option B also answer according to old update, old rule. The B is option, but in new update, how to tell the name Cl minus mean? What is Cl minus? That is called chlorido, not chloro. Okay, this is a new update. Please note this point, very important. According to new update, what is option? Option D is correct answer. Okay. And third question, they are asking what? The ligand property. Now note, very important point, note. Whenever I give the note means very important point. Okay. The CO ligand and CO and Cn minus, they are strong field ligand. They are strong field ligand. Okay. As well as what? They as well as the good pi acceptor. Okay, pi acceptor. Now see the option C. CO is actually weak field. Okay, not weak field, the strong field, right? The CO is a strong field ligand and good pi acceptor, but Cn is not. Okay, Cn also what? Strong field also good pi acceptor. So what is the correct option? Option A is correct. What is option A? The CO is a strong field ligand and a good pi acceptor, and so is Cn minus. Okay, the option A is correct for this question. And fourth question is asking what? The hybridization. Which hybridization? D2sp3. What is D2sp3? They call inner orbital complex. This inner orbital complex. Inner orbital complex. When the inner orbital complex take place, whenever the strong field ligand, okay, the inner orbital, right? The Cl, weak field ligand, there is no possibility. Fe, weak field ligand, there is no possibility. In case of 2, right? In this nickel D8. D8 always form what? Outer complex. What is outer complex? sp3d2. Now, what is correct answer? Option B. Okay, listen. Without drawing the VBT theory, we can find out the hybridization. Okay, if your basic is very strong, we can find out. Okay, always inner orbital complex. Generally, the 90% always form what? The strong field ligand can form what? The inner orbital complex compared to weak field ligand. Therefore, option B is correct. Okay. And next question, they're asking what? In the octahedral complex ion and T2G orbital, right? Listen. This 1, 2, 3, 4, 5, 5 energy level, right? So split into what? 2 energy level. In case of octahedral, this is T2G, this EG. Okay, this is EG, this T2G. What is T2G level? DXY, then DYZ and DXZ. This is DX square minus X square minus Y square. This what is correct option? This is triple E, 3 energy level, right? Triple E degenerate. This is double degenerate, right? What is correct option should be? The triple E degenerate, right? W is cancelled. Okay. Which answer should be DXY, DXZ, and DY is option C is correct for this question. And next question they are asking what? Good question. Which are the following transition metal ion should be smaller size? Listen. In general, we know, right? In general, okay, I take A plus and A minus. Which is more atomic size? A minus, right? A minus, then followed by neutral ion, then followed by A plus. Okay, this is first value, general. What is general? Next thing, left to right. Okay, left to right. Whatever size, left to right. Left to right, size will be decreases, right? But this rule not applicable for transition metal because, please note, very important point, note, the size of transition metal, the size of, okay, TS, transition metal, it depends on, okay, CFSE value. Please note. No, what is size formula? The size equal to what? Size equal to the size bracket la without CFSE. Without CFSE plus CFSE value of metal ion. Okay, now see, size always positive value, right? And CFSE always negative value. Now you know understand, okay, higher the CFSE value of metal ion, higher the CFSE value of metal ion. What about total size, resultant size? This is a resultant, okay, net. Okay, what about net result of size? Size will be decreases. Now you know very well the chromium 3 plus and titanium 3 plus and vanadium 3 plus and Mn 3 plus, which is IS CFSE, the chromium 3 plus. Therefore, this is D3 configuration, right? Therefore, which is IS CFSE value, which should be chromium 3 plus. IS CFSE means on smaller size. There should be option A is correct for this question. Okay. And next question, they are asking what? The term symbol for nickel 2 plus. Simple, right? First write the configuration. Nickel 3D8, 4s2, right? And nickel 2 plus means D8 configuration. Now draw the diagram. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, right? This is -2, -1, 0, +1, and +2. What is S value? S equal to 1. What is the spin multiplicity? The spin multiplicity is equal to what? Multiplicity. What is the formula? 2s plus 1. What is the S value here? 1. Therefore, 2 into 1 plus 1. Option 3. Okay. If you find out only spin multiplicity, I get the answer. No need to find out what? L value. No need to find out J value. Okay. The poor question designer, right? We can using spin multiplicity. I can find out the answer. What is L value here? Okay. This 2 plus cancel. This also cancel. L 1 plus 1, 3. L value is equal to 3. That means what? F orbital. Okay. This means F orbital. F term, right? So F term. Okay. Triplet F. What is it actual? What is actual notation term symbol? Put L and 2s plus 1. Then what? J value. This is what? The actual term symbol notation for the atomic orbital. Okay, atomic, atoms, not molecule. Molecule different, right? You put the, okay, plus minus and GU parity rule. You have to apply what? Spin selection rule for what? That molecular orbital, a molecular term symbol is atomic term symbol. Okay, please. So this for atomic term symbol. This for what? Atomic term symbol. Okay, and next question. This is good question. Okay, just now we discussed, right? Based on selection rule. The correct statement among the selection rule of electrons, and please note, very important note. The selection rule. The selection rule for, please note. the selection or rule for electronic transition. What is the rule? First rule, Lepati rule. Lepati. What is Lepati rule? Delta L equal to 0 plus or minus 1 is allowed. Second rule, spin selection rule. Spin rule. What is spin rule? That is delta S is equal to 0. Okay. Then third one, parity rule. What is parity rule? Very simple. Gerate to gerate. Forbidden. This is forbidden. Okay. Forbidden. Okay. Ungerate to ungerate. This is also forbidden. Forbidden. Then gerate to ungerate. This allowed transition. Allowed. You tick. Allowed. Okay. This is allowed transition. Allowed. Then ungerate to gerate. This also allowed. This is the three important rule for what? Electron transition. Now see the option. The electronic transition involving the changing the parity, right? There is changing the parity, right? G to E is allowed. U to G is allowed, right? The same parity is not allowed. And between what? The same multiplicity, okay? This one during the electron transition, okay? The spin multiplicity cannot change. I give you an example for what? The selection rule for molecular terms rule, okay? Now take the example. This you can using this example, you can understand all the rule, okay? Now see this example. Pi and 2 and summation of 2, okay? Now the pi L value is equal to 1. This L value is equal to 0. What is total L value? It should be what? Plus 1, right? Allowed, right? This allowed. Then there are this spin delta is same, right? Delta S 2 minus 2 also 0, allowed. Yes or no? G to G allowed. Okay. In case of pi, we cannot use G and U, right? Only use for what? Only sigma orbital, right? Sigma term symbol only. Okay. This what is option? Correct option. Option A is correct. Okay. Now during the spin selection rule, electron transition, we have to apply three rule. What is three rule? Lepati rule and parity rule. Then what? Spin selection rule. Understand? I go for next question. It's ninth. They're asking what? Which of the following complex are more likely the deviated from the spin orbital magnetic momentum? They're asking what? Indirectly they're asking the orbital contribution. Orbital contribution. Listen, please note. When orbital contribution can take place? Sorry. When orbital contribution can take place? Note. Note. Very important. When the orbital contribution take place. What is the condition? Listen. The unsymmetrical. Very important. Unsymmetrical electronic arrangement. Unsymmetrical and electronic arrangement in T2G energy level. Okay, whenever the T2G energy level should be unsymmetrical, that case what? We have to expect what? Orbital contribution. The orbital contribution what? They're going to what? Deviate the spin only magnetic momentum. According to the all four option, which is correct answer? Option D is correct, because option D, the go ball is 2 plus configuration, right? 2 plus means D7, right? Then put the energy level 1, 2, 3 and 1, 2, 1, 2, 3, 4, 5, 6 and 7. Therefore, T2G is what? Unsymmetrical. Therefore, go ball 2 plus can show what? Orbital contribution. Therefore, this complex what? The more deviate from the spin only magnetic moment. Option D is correct. And next question. Okay. Which one of the following molecule did odd one out? Okay. They're asking what? The bonding property. Now you know CO3 minus, they contain double bond, right? Double bond and O minus and O minus. And SO3 double bond O and double bond O and double bond O. CH4 all the single bond and BF3 also all the single bond. But what is the specialty of BF3? They contain under boron sp division, right? That can d orbital. Fluorine 2p. This also 2p. That has possibility. Back bonding possibility. Therefore, what is structure of BF3? Boron with double bond F, here F and F. Therefore, which one is containing only sigma bond? This is a unique bonding property, because CH4 all are sigma bond. And other three molecules they containing what? Pi bond. The option C is correct answer. Understand? Okay, in BF3, due to the back bond, when the back bond is possible, any one of the atom belong to second period, right? The other atom should be containing electron donor. That case, the back bonding can be possible. In BF3, the 2p back bonding more effective. Therefore, they form the double bond. The bond of BF3 is always what is value? Not 1. Answer should be 1.33. Okay. And next question, they're asking what? The main reason for what? The tris biphenyl ion 2 plus. Okay. Now going to tell very important point. Please note. Please note. This is the first point. The metal, if electron rich or rich, now first metal electron rich, and second, the metal is lower oxidation state. Lower oxidation. What is lower oxidation state? -1, 0, and +1 and +2. They are lower oxidation. Okay, +2 also what? Lower oxidation state. And second thing what? The ligand. Very important point. Put the star on this one. The ligand. Okay, the pi acceptor on this now. Pi acceptor ligand. This in three conditions, they able to what? They form the MLCT spectra. Okay, metal to ligand charge spectra. Okay, whenever the metal should be electron rich or in the metal lower oxidation or in the ligand when the pi acceptor ligand are in the possible MLCT possible. Now, what are the pi acceptor ligand? We know very well CO, Cn minus and bipyridine, right? Bipyridinyl. These are what? These are good pi acceptor. Therefore, in the option, what is the ligand will be there? Bipyridinyl. Therefore, which is possible? The metal to ligand, the charge spectra possible for this complex. Now, understand what is the condition for MLCT? Metal should be electron rich and metal have lower oxidation state and ligand have good pi accelerator means the metal to ligand, the charge spectra can be happen. Therefore, this question option B is correct answer. And next question they are asking what? The John Taylor destruction, right? Now you know very well whenever the unsymmetrical arrangement in which now we can expect the John. They are asking what? The maximum, right? Maximum. When the maximum, listen, note, key point. The maximum John Taylor destruction, when happened? EG is unsymmetrical. EG unsymmetrical, right? EG is unsymmetrical. Therefore, which is correct answer? We know the copper 2+, right? The copper 2+, they show what? The D9 configuration. D9 mean 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. Therefore, D9 what? Totally unsymmetrical. What is option? Option A is correct answer for. Listen, whenever T2G, EG is unsymmetrical, they show what? Maximum John Taylor destruction, right? And the EG unsymmetrical, T2G unsymmetrical, and that is a static John Taylor destruction, and EG unsymmetrical, that is the dynamic, right? Dynamics more give the more destruction compared to what? Static. Therefore, option A is correct answer for this question. Okay, now go for next question. They're asking what? The most abundant metal in a human body. Okay, listen. In carbonic anhydrous, which metal is present? Zinc metal. Zinc, okay. In case of oxygen transport ion, Fe is present. In case of vitamin B12, cobalt is present. In case of cobalamin, hemocyanin, copper is present. In among the four molecules, which metal have highest of human body? The Fe is correct answer. Okay, Fe is for like human containing what? The more Fe content compared to zinc and copper and cobalt. Therefore, option B is a theory. This is a bioorganic question, right? If you know the basic configuration, if you know the metal, carbon and means zinc, you have to know. Vitamin cobalt, you have to know. Hemocyanin, you have to know copper, right? Now, among the four, which is higher content in human body? Fe. Therefore, option B is correct answer. And let's go for next question. They're asking what? Which are the following most likely to undergo oxidative addition? Please note. I'm going to give the point now. Note. The oxidation addition. The oxidative addition. When is favored? Listen. Always, please, very important. Always the 18 electron complex. The 18 electron complex, okay, do not undergo oxidative addition. It's a key point. Next, what is important point? The 16 electron complex is always favored. The favor for oxidative addition. Now, among the four options, which is listen, these are 18 electron. This 18, which is 16 electron. This 16 electron. How is 16 electron? Cobalt, rhodium, that 9, right? Cobalt, rhodium, iridium, 9. Cl, 1 electron donor. And phosphine, 2 electron, 2 into 3. Therefore, answer 16. Option A is correct. Okay, always what? The 16 electron complex favor for undergo oxidative addition. Option A is correct. And next question, they are asking what? The correct rank for the bond order, right? O2 plus and O2 minus and CO and O2 plus. We know the trick, right? What is a small trick? I already uploaded the bond order trick in our channel. Okay, you go and visit the playlist and watch the bond order tricks. It's simple. Listen. In case of 14 electron, okay, in case of 16 electron. 14 electron means bond order is 3. This is bond order. Okay, bond order is 3. And 16 bond order is 2. This is in 15. Okay, here 15, listen. Here 15, here 13, here 12, here 17 and 18. Okay, now we have to subtract 0.5. 0.5, 1.5. Here 1. Here 2.5. Here also what? 2.5. Here 2. Okay, this is electron count. This is a bond order. Okay, now see O2. We know O2, 16 electron, right? What is O2 plus 15 electron, right? O2 mean bond order is 2. O2 plus mean 2.5, right? Only one option is 2.5. Therefore, option D is correct answer. Simple. O2 minus, which 17 electron complex. What is bond order? 1.5, right? 1.5. Then CO. Okay, there should be what? CO what? Also 14 electron complex. What is bond order? 3. Simple. O2 2 minus 18 electron complex. Bond order is 1. Option D is correct. Very simple question. Okay. Let's go for next question. Asking what? The theoretical magnetic momentum for gallium 3 plus and europium 3 plus. Okay, this is very important question. Please note. Okay. In general, for F-log element, okay, we do not apply this formula, right? Means equal to square root of n into n plus 2. This only for spin only magnetic momentum. Okay, but in F-log element, okay, the orbital momentum is kunch, right? There will be what? There also what? The orbital momentum can be observed. Not only spin value, the L value also dominated. Therefore F-log element, what is the spin? What is magnetic momentum value? The F-log element. What is general formula for F-log? Means equal to and G into and square root of J into J plus 1, right? What is the formula? G into mu is equal to G into and square root of and J into J plus 1. Okay. In the F-log element, in 14 element, galvanium 3 plus, this metal have only what? Only spin only. Only the spin only value. Spin only value. Therefore, the galvanium 3 plus, what is configuration? The 4 of 7, right? The 4 of 7 unpair, right? 7 unpair mean what? Therefore, what is value around? 7.9 value. Therefore, option A was 7.9, on option C 7.9, on option B and option D is cut. Let's go for europium 3 plus. In europium 3 plus, what is the configuration? This will be 4F6. Now write the configuration 1, 2, 3, 4, 5, 6, 7. This is minus 3 and minus 2 and minus 1, 0 and plus 1 and plus 2 and plus 3. Okay. Then 1, 2, 3, 4, 5, 6. Find out the L value. What is L? This 2 cancel. This one cancel. What is L value? 3. What is L value? S value of plus of 1, of plus of 1. Therefore, L is equal to S equal to 3. Okay. This is what? Okay, this is less than half field, right? Therefore, J is equal to what? L minus S. What is L minus? What is L value? 3. What is S value? 3. Therefore, J is equal to 0. Put the J value 0 mean square root of 0 into 0, 0, 0, 0 into 0, 0. Answer should be what? Option A is correct. In case of europium, you can apply what? This formula only, not spin only. In F-log element, galvanium 3 plus only, we have to apply the spin only formula. Another matter you can apply for G, mu is equal to G into square root of J into J plus 1. You can apply for the find out the magnetic momentum. Therefore, option A is A for this correct answer for this question. Okay. And next question is asking what? The how many spectral line are expected to what? Electron D8 configuration. You have to know the orbital diagram first. Orbital diagram தெரியாம question solve பண்ண முடியாது. I going to give you some important point. Okay. Nickel and En tries and 2 plus. What is the configuration of nickel here? Nickel 2 plus, right? And nickel 2 plus. What is the configuration? D8. In D8, okay, it should be ground state. Ground state are, so what is the term? 3F. Are the excited state are in the first excited state? What is the term that is called 3P? Okay. F term are now 3 Mulligan symbol possible. How many Mulligan symbol? Mulligan symbol. The 3 possible. 3A2 plus 3T1. T1, we put F term, right? Then 3T2. In case of P term are this, only one possible. That is called what? 3T1P. Okay. T1P. Okay. If you apply the orbital diagram, how many spectrum will be possible? The answer is the 3 is possible. Listen, we have to draw this like, okay, this F term, F3. This is P3. You can write this like 1, 2, 3. Then you have to 1, 2, and 3 lines possible. Okay. How many lines possible? There are 3 lines possible for what? This D8 count. Option D is okay. I will put the one more video about the orbital diagram and as soon as possible. How can find out the spectrum line for D8 configuration and this is configuration, D2 configuration. Okay. We will see the soon. Okay. How can find out the spectral diagram? How can find out the line of the line of the complex. Okay, you can discuss very soon. The next question, 18. Okay, they're asking about trans effect. Okay, they're asking trans effect, right? Please note trans effect series. Note trans effect series. I'm going to give you the trick. In general, trans effect, listen, carbon donor, highest trans effect, then followed by what? Halogen donor, followed by halogen donor, then followed by nitrogen donor, and finally oxygen donor. You can apply this trick to get the answer. Carbon donor, CO. Option B is B also, right? A NH3. In carbon donor, CO is strong ligand CN, right? Compared to CH3. Therefore, this also cut. And two option A or C. Okay. This carbon donor is nitrogen donor, which is highest donor, carbon donor, right? Therefore, option A is correct. Okay, the carbon donor, then halogen donor, then nitrogen donor, finally oxygen donor. Okay, this is order for what? A trans effect series for the concept. Next for this question. This is, listen, in general, going to give the trick also for this question. In generally, okay, the tetrahedral complex, they are more labile compared to octahedral. Okay, now they're asking incorrect statement, right? Now see the option of D. They're asking what? NaCN4 2-, they are kinetically inert, right? But actually kinetic labile. Okay, using this trick, you can find out the option. Option D is the correct answer. Listen, this you have to understand what? How to listen. There are questions combined with what? And labile inert, right? We have to know the configuration of metal ion and D3, D1, D2. We have to write the configuration. Then only you can find out what? An inert lability concept. Okay. This concept also I will discuss later in coordination chemistry playlist. Okay. And next question, they are asking what? The oxidative potential for the cobalt 2+ to cobalt 3+. Okay. The cobalt 2+ convert to what? Convert to cobalt 3+. Cobalt 3+. We know very well the cobalt 3+ strong field ligand, right? In the presence of what? Listen, note. Very important. Cobalt 3+ kuda. Okay. I minus, Cl minus, SCN minus, இந்த லிகாண்ட தவிர மத்த எல்லா லிகாண்டுமே ஸ்ட்ராங் ஃபீல்ட் லிகாண்ட் தான். புரியுதா? இந்த கோபால் 3+ல வந்து இந்த 3 லிகாண்ட் I minus, Cl minus, Br minus, SCN minus இந்த 4 லிகாண்ட தவிர மத்த you put any ligand, that ligand is act as strong field ligand. Okay. இந்த கொடுத்த ஆக்சலேட்டோ எத்திலீன் டையமீன் H2O ல எது வந்து more oxidation potential பார்த்தா what is more oxidation potential? Is based on electrochemical potential series. Okay. Therefore, what is correct option? The C of C reaction should be what? The more favor compared to what? Oxalato, ethylene diamine, ammonia. Option C correct answer. Okay. And next question I'm going to discuss what? They ask inverse final. Now going to teach a trick for inverse final. Please note. Inverse final. Listen. What is final concept? AB2O4, right? What is the concept? AB2O4. AB2O4. Now see. If B atom வந்து FeR இருந்துச்சுனா, listen, if B atom FeR இருந்துச்சு, please note, Fe3+ complex இருந்துச்சுனா spinalல, okay, it always inverse. It always inverse. When is always inverse அப்படினா, நல்லா புரிஞ்சுக்கோ, side atomோட CFSE value, side atomோட CFSE value not equal to 0 இருந்துச்சுனா, okay, Fe3+ complex always inverse. Trick. You got the point. Now you know very well their Fe is present, right? And nickel 2+, D8, right? D8 what? That will be CFSE is not equal to 0 only, right? Never can be 0. Therefore, option D is correct. If you know this trick, you can find out the answer. In case AB2O4, Fe3+ always inverse. Epa inverse ஆக முடியும்? Side atom CFSE வந்து not, for example, like this Z10, okay, and Fe2O4. This is normal spinal. This is normal spinal. Why this normal? Because Z10 zinc 2+ side CFS is 0. CFS is 0. அதே மாதிரி Mn Fe2O4. This is normal spinal. Why normal spinal? Mn 2+1 DCFS is 0. அப்ப side atom CFS is 0 இருந்துச்சுனா normal spinal. அதே side atom CFS is not equal to 0 இருந்துச்சுனா always Fe complex should be what? Fe3+ always what? Inverse spinal. Okay, this trick you can apply. And next question, okay, they asking what? Peroxy linkage. It's a very simple question. We take this H2SO4. What is H2SO4? The well-known compound, right? Carose acid. This is carose acid. This is carose acid. What is carose acid? This is a peroxy acid. Okay. This is a peroxy acid. What is the formula? S and double bond O and double bond O. Here O OH, here OH. Therefore, H2, right? H2, 1 sulfur, 1, 2, 3, 5, S2, SO5. This carros acid. This is a peroxy bond. This is a peroxy bond. What is option? Option B is correct. Okay. And final question, they're asking what? Which are the following complex metal ion? They show the lowest oxidation state. Okay. In case of option A, this is 0, right? This -1. Okay, this -2, right? Therefore, it should be +2 or +3. In case of Fe, listen. In case of Mn2 CO10, listen, this structure. Mn, I have metal bond. Here also Mn, then here also CO ligand, here CO ligand, and CO ligand, and CO ligand, 1, 2, 3, 4, right? And 5. Similarly, this CO and CO and CO and CO and CO. Listen. In generally, CO is neutral ligand, right? CO is what? Neutral ligand. Therefore, in case of metal bond, you can split it to -1. Therefore, what is the oxide metal ion? Mn is -1 oxidation state. What is the oxidation state? The minus oxidation. Understand? Therefore, option C is correct for this question. Okay. In case of Mn2 CO10, they metal bond -1. Okay. If you take all the other 3 options, metal on the positive oxidation. Okay. I hope you understand all the 23 questions, whatever I discussed till now. Okay, thank you so much for watching. And as soon as possible, I'm going to upload what? The CU-CET 2020 inorganic and the organic and the physical question paper. And tata, bye-bye.